Hello and welcome to Astronomy Daily, the podcast bringing you the biggest news from across the cosmos. I'm your host, Avery.
And I'm Anna. It's great to be with you. Today, Avery, we're talking about a threat to one of Earth's best windows to the universe, some big reveals from Blue Origin, and a star that's singing a strange cosmic song.
That's right. Plus, we'll dive into why time literally moves faster on Mars, and a fascinating new idea for building Martian homes using bacteria. Let's start with that story from Earth, Anna. It sounds pretty serious.
It is. We're talking about Chile's Atacama Desert, home to the Paranal Observatory and the Very Large Telescope. It's one of the best places on the planet for astronomy because of its clear, dark, and stable skies.
An absolutely critical location for science.
Exactly. But now that's under what some top scientists, including a Nobel laureate, are calling an imminent threat. A massive renewable energy project is planned for a site nearby. While green energy is vital, the scale of this project has astronomers deeply concerned.
So what are the specific worries? Is it just light pollution?
That's a big part of it. The project could brighten the night sky, kick up dust that obscures faint objects, and the heat could disrupt the stable atmosphere that makes imaging so sharp.
Wow. So it's a triple threat to visibility. It's a tough situation, a conflict between two positive goals, advancing sustainable energy and protecting our ability to explore the universe.
It is. The open letter from the scientific community isn't trying to stop the project, but to raise the alarm and work with the developers to find a solution that mitigates these impacts. Hopefully, a compromise can be found.
It's a truly delicate balance. Are there any specific technical solutions being discussed? I imagine it's more complex than just asking them to build it somewhere else. We're talking about things like specialized light shielding or perhaps operational agreements to limit dust-creating activities during critical observation windows at night.
Precisely. They're suggesting technical solutions like advanced dust suppression, special lighting to minimize sky glow, and even pausing industrial activity based on observatory schedules.
Let's hope so. From a project threatening our view of space, let's turn to one that's actively building our way into it. Blue Origin has been making some serious announcements.
They've been very busy. Fresh off a successful New Shepard launch, they pulled the curtain back on a lot of new hardware.
They sure have. First, they unveiled the Blue Moon Mark I robotic lander, scheduled to fly by 2026. It's the precursor to the crewed lander for NASA's Artemis 5 mission.
Right. This is their cargo version. It's designed to test the landing systems and deliver payloads to the lunar surface ahead of the astronauts. They also announced a more powerful version of their new Glenn rocket, right?
That's right, the 9x4 variant. But what really caught my eye were the other two announcements. They revealed details on something called Blue Ring, which is essentially a space tug. It can host payloads, refuel other spacecraft, and basically act as a logistics vehicle in Earth orbit and beyond.
A space tug makes sense for building out in-space infrastructure. And what was the last one? Something for Mars?
Exactly. A new deployable aerobrake technology, like a giant parachute, using a planet's atmosphere to slow a spacecraft for future Mars missions. It shows they're thinking about the entire ecosystem of space exploration.
And that's a huge piece of the puzzle. We hear a lot about launching things, but not as much about what happens once they're up there. A versatile platform like Blue Ring could be used for satellite servicing, refueling, or maybe even tackling the growing problem of orbital debris, right?
Exactly. The long-term vision is a sustainable cislunar economy. We're talking about a future where space isn't just a destination, but a domain for industry and commerce. A vehicle like Blue Ring could refuel satellites, giving them a new lease on life, move infrastructure into place for future space stations, or even act as a mobile data relay. It transforms orbital space from a passive location into a dynamic workspace.
It's an ambitious roadmap. Speaking of ambitious missions, NASA's test satellite, the Transiting Exoplanet Survey Satellite, has helped uncover a fascinating cosmic mystery. It's about a star that's singing a very strange song.
Singing? Tell me more. Are we talking about vibrations?
In a way, yes. Astronomers detected starquakes from a red giant. These seismic waves cause the star's brightness to vary, which is how TESS detected them. This star is orbiting a black hole known as Gaia BH2.
Okay, a red giant and a black hole. That's already an interesting pair. So what's so strange about the starquakes?
Well, the data revealed a couple of odd things. First, the star is spinning way faster than a red giant should. They tend to slow down as they expand. Second, its chemical composition is weird. It seems to be relatively young, but it's made of very ancient materials. It's low in heavy elements.
Young, but made of old stuff and spinning too fast. That doesn't add up. What's the theory?
The leading hypothesis is a dramatic one, that this star is actually two stars that merged. A cosmic merger would explain both the strange chemical mix and its high spin rate.
It really is. And the fact that they could deduce all this from tiny fluctuations in starlight is incredible. This field of astroseismology, studying starquakes, is like listening to the inside of a star with a stethoscope. It's revealing details we could never see directly.
It's a perfect example of multi-mission astronomy. Gaia provided the position and motion, while TESS provided the internal diagnostics. Combining the data let them piece together a hidden history.
From cosmic collisions to cosmic clocks. And I saw a story that sounds like it's straight out of science fiction. Apparently, time itself moves at a different speed on Mars.
It does, and it's not science fiction, it's just pure Einstein. Based on calculations from his theory of general relativity, time on Mars passes slightly faster than it does here on Earth.
How much faster are we talking? Am I going to age noticeably quicker if I move to Mars?
Hardly. The difference is a tiny fraction of a second per day. It comes down to relativistic effects. Mars's weaker gravity and slower orbit mean time passes slightly faster there relative to us.
Okay, so I won't need extra anti-aging cream. I believe the figure is 477 microseconds a day. That sounds small, but I bet it adds up when you're dealing with high-precision technology.
That's the critical point. Just like our GPS satellites, future Martian missions will need to account for this time dilation for synchronized communications and navigation. It's fundamental for our interplanetary future.
It really puts into perspective how interconnected everything is at that level of physics. Does this also mean we'd need a separate time standard for Mars? Something like coordinated Mars time, similar to UTC on Earth?
That's exactly what space agencies are working on. A defined Martian time standard is essential for mission coordination. Without it, every mission would be using its own reference frame, leading to chaos. It's not just about convenience, it's about safety and precision. Imagine trying to coordinate a landing while your orbiter and ground control are seconds out of sync. Establishing a common clock that accounts for the relativistic drift is a foundational step before we can have rovers, orbiters, and future human bases all working in perfect sync. It's a complex problem of interplanetary timekeeping that has to be solved.
Speaking of our interplanetary future, let's talk about actually living on Mars. Our final story today is about a really innovative approach to construction on the red planet, using what scientists call in situ resource utilization.
Right, the idea of living off the land. It's far too expensive to launch everything we'd need from Earth, so we have to use what's already on Mars.
Exactly, and this new proposal is brilliant. It suggests using Martian soil, or regolith, mixed with two specific types of Earth bacteria to create building materials.
Bacteria as cement mixers? How would that work?
It's a two-part system. The first bacterium, Sporosarcina pasteurei, creates calcite, a powerful binding agent. When mixed with Martian soil, it creates a solid, concrete-like material, bioconcrete.
That's incredible. So you can create bricks and foundations right there. What about the second bacteria?
That's where it gets even better. The second one, Caracoidaxis, is a type of cyanobacteria. Its superpower is photosynthesis. It would be engineered to take in the Martian atmosphere, which is mostly carbon dioxide, and sunlight, and produce oxygen as a byproduct.
So you get building materials and a life support system in one package. One set of microbes builds your house, and the other helps you breathe inside it.
That's the concept. It's a truly elegant solution that integrates construction and life support. We are essentially using nature's own nanotechnology to solve monumental engineering challenges light years from home. It's still in the early stages, of course, with huge hurdles around planetary protection and ensuring these microbes perform as expected in the harsh Martian environment. But it's this kind of creative biological engineering that might just make living on Mars a reality, turning the planet's own resources into a sustainable habitat.
Okay, that's a game changer. But what about the conditions on Mars? We're talking about extreme cold, low atmospheric pressure, and intense radiation. Can these Earth-based bacteria actually survive there long enough to do their jobs?
That's the focus of the research. One of the bacteria is an extremophile, incredibly tough and radiation resistant. The plan is to use them in shielded bioreactors to create building materials in a controlled environment.
And what a future that would be. And that brings us to the end of today's episode of Astronomy Daily. From protecting our view of the stars in Chile to listening to their songs and even planning our homes among them, it's been quite a journey.
Thanks for tuning in. Join us again tomorrow as we continue to explore the universe. Until then, keep looking up.